When we are speaking about Earth's surface environments, that is geomorphology basically, the first thing that we need to concentrate on is what sort of processes are we looking at, or at least look at the surface and think about to what extent internal or external factors took some kind of role in forming the landscape. So we need to make a distinction between what is from inside and outside the planet. So if we think about the surface of the planet, there are some forces that would come from kind of inside, and that is one of those internal forces that were discussed already in the earlier module, Planet Earth. Here we can think about volcanic activity, plate tectonics, the geothermal heat. So anything that is related basically to the internal heat, the internal energy generation that comes from within the center of the Earth. And internal, we can also call the endogenous. If I'm correct with the spelling, endogenous forces would be what we call the internal. And also we need to think of what is external. So those kinds of processes or forces that come from the energy basically of the sun. And these would be then opposite to internal, external. And we can also call these then exogenous forces, as we already seen in the lectures. So in the first and the second lecture, these are being discussed more in details. So if we're speaking about geomorphology, very often it's much more the external forces that will be of interest. Obviously, mountains will be developed, so the surface, the structure of the surface, or here we can think to some extent like isostatic rebound, plate tectonics, orogenesis, and so on, that are developed partly at least by the internal forces, but much more it will be the exogenous or external forces, such as the work of wind, ice, water, that will be all basically driven by the energy that comes from the sun. So the rays of the sun, as they will heat the surface in different ways. So these are what would make most of the surface look the way it does on our planet. So if there's kind of a question in the exam to tell examples to external or internal forces, we need to know what these might be. So volcanoes versus the work of the wind or the water or the ice. And obviously what we see on the surface at the end of the day will be an interplay of these two. So isostatic rebound, plate tectonics, whatever orogenesis, these will be together what force the planet surface to take a certain kind of shape. Also, there was a specific term that we were using in the first two lectures, and that's equifinality. This is basically a process or phenomenon much more which is built up of, as we see here, two different words, equal, and final. So finality, that's how we can remember this word. Equifinality will mean that there are different kinds of forces or factors shaping the surface of the planet. But actually, when we just look at how does the surface here look like, we won't actually be sure about what made those specific landforms look the way they do. So an example to this would be ripple marks. Ripple marks would be usually developed, say, in like a sand-dominated surface. So here we have these little, more or less like parallel kind of ridges of sand. So there's a little valley and a little ridge. So these are the higher levels or higher altitudes, and there are the little valleys. So if we think of this kind of cross section here, how sand with the beach would look like, we might also think whether this specific area would be developed by wind or water. And just by looking at the surface itself, looking at ripple marks, so we will not be able directly to tell what the main cause of the development of this surface would be, because two different forces or factors would have the same final outcome, final look. That's why we call this phenomena equifinality. Obviously, we can also say, as we already know, there will be things like here for wind. And in the water, we said that sediments would be moving in a similar way through saltation. Saltation will be present in forming wind-shaped surfaces as well. So this tiny bouncing of the particles, sediment particles, sand particles, we can think of in both cases it's being saltation. And probably it's the fact that saltation would be present in both of these environments or both of these forces. That's why we would be able to find the kind of resulting pattern of the surface that would look pretty much the same, even if we are in a completely dry or completely wet environment.